Today we're going to look at adding polynomials. So a polynomial is just an expression that has multiple terms in it. So for instance, inside each set of these parentheses here, we have a polynomial. These sets of parentheses are just to say, this is one polynomial, this is another polynomial. Since we have a plus sign in between them, that means we need to add the polynomials together, which sounds kind of crazy, but really it's not too bad. When you're adding polynomials, all you need to do is combine like terms. That is it. So, friendly reminder for like terms have to have the same variable in them, and the variable has to have the same exponent as well. So let's just go through and combine our like terms, and that's all we have to do for this problem. I always like to start with the largest exponent. You don't have to do that, but it helps me keep organized. I'm not going to be picky with your final answers as long as you have all the right numbers in the right places. So, starting with my highest exponent, which is 4, 5n to the 4 and 6n to the 4, combining those 5 plus 6 gives me 11n to the 4. Remember that when you're combining like terms, you add the coefficient part, but the exponent part stays the same. Let's keep looking for more like terms. Let's go down to our next exponent, which would be 3. 4n to the third, 5n to the third. 4 plus 5 gives me 9. The n to the third part stays the same. Next up, squareds. I have a 5n squared, 5n squared. 5 plus 5 is 10. The n squared part stays the same. Now we have a couple of things that won't combine with anything else, so we're just going to leave them alone. This is the only term with just an n in it, so it stays just plus n. This is the only just number term, so it stays minus 1. So my final answer here looks like this. The rest of these all work the same. We're just going to do a little more practice. The only thing that gets a little different is for these bottom two, we are combining 3 polynomials. But just make sure you find the like terms in all 3 parts, and you're good to go. So, let's use the same process. Biggest exponent I see here is a 3, and I haven't, oh no, I lied. Sorry, the biggest exponent I have in this problem is a 4th power, which is right here. That is the only term in all of these that has a 4th power, so 7p to the 4th will not change. It'll be part of my final answer. You want to mark that you're done with that, though you can, just so you don't lose track of things. Now, I can do my third powers. P to the third, p to the third. 2 minus 3 is negative 1. P to the third, or if you'd rather, you can just write negative p to the third. They mean the same thing. Next up, let's deal with second powers. I have a second power here. No other second powers anywhere else. So my 4p squared is just going to stay a 4p squared. You want to check off that you're done with that? Go for it. Regular p terms. I have 3p and 6p. 3 plus 6 is 9. The p part stays the same. And then number terms. Negative 8, negative 5. Negative 8 minus 5 is negative 13. I can't do any more combining because none of these that are left are like terms. So that's my final answer. Like I said, these last couple might look really scary. You're just adding like terms between 3 polynomials. So make sure you just find all of the like terms and combine them together. My biggest exponent I see in all of these is a 4th power. So I have negative 7, negative 6, and a negative, which is like a negative 1. Negative 6 minus 1 gives me negative 14. P to the 4th part stays the same. Third powers, negative 2, negative 3, positive 3. Negative 2 minus 3 plus 3 gives me negative 2. The p to the third part stays the same. Squareds, I have 6, hidden 1, and nothing. 6 plus 1 gives me 7p squared. We do not have any regular p's here, so we have no regular p terms in our final answer. Numbers though, 6 minus 5 plus 1. 6 minus 5 plus 1 gives us 2, positive 2. Don't forget that plus sign in front. Double checking our answer, we do not have any like terms to combine, so we are finished. All right, last but not least, Looking for my biggest exponents, fourth power, fourth power, fourth power. That's where I'm going to start. 8 minus 7 plus 6 gives me positive 7 r to the fourth. I'm going to go down my list. Third powers be next. Third power here, third power here. 6 plus 8 gives me 14 r to the third. I don't have any r squareds, which is fine, not a big deal. So then the next thing on my list would be regular r's. 3r, 2r, regular r, or 1r. 3 plus 2 plus 1 gives me 6r. And then numbers. We have -3, positive 1, positive 2. So -3 plus 1 plus 2 is 0. You could technically write a plus 0 there, or another way you can think of that is that they just all cancel out. And so usually when it's a plus 0, we don't write it. So this right here would be my final answer. You do not need to include the plus 0 because your number terms have just all canceled. That is it for adding polynomials. Have a fantastic day.